I'm back with another chapters. So today we will be going to discuss work energy power, and after that we'll take mechanical properties of solids. So these two are the chapters which we have to discuss. Again, I'll give you a brief overview of the topics, and we'll do some questions also so that you understand each and every topic in detail. So let's start. So the first thing which we have to discuss is the concept of work. Okay. First we have to discuss the concept of work. Now what basically is work? According to physics, work is nothing but the dot product of force and displacement. Whenever there is a particle on which there is a force being applied, and because of that force there is a displacement of the block, then basically a work is said to be done on the particle. So basically if there is a block of mass m and you are applying a force F on this particle, suppose the angle is theta, and because of that the block got displaced by a displacement S vector, then I will say work done will be equals to what? Small work done will be equals to F vector dot ds vector, and you have to integrate it from given limits. This is the actual definition of work, F vector dot ds vector, where ds vector is the small amount of displacement on the application of force. So let us call this displacement as ds vector. Now if this particular force will be constant, so please remember, if this force will be constant, whenever you are displacing the block and the force applied is constant, then directly you can remove this integration and you can directly write F vector dot S vector. So this is basically the calculation of work done. Whenever the force is constant, you have to apply this concept, F dot S. Whenever the force will be variable, then you have to apply this concept, integration of F vector dot ds vector. I will take numerical so that you understand all these concepts. Now one more thing, suppose your particle is displaced from initial position, whose coordinates are given to you as x1, y1, z1, and you are displacing it to final position, whose coordinates are given as x2, y2, z2. So basically you are going from point A to point B like this under the application of a constant force. Okay, right now I am discussing about constant force only. After that we will take the variable force case also. So if constant force is being applied, then the work done can be written as, directly we can write F vector dot displacement vector. Now what will be the displacement vector? Displacement vector will be final position, that is x2 i cap plus y2 j cap plus z2 k cap minus of x1 i cap plus y1 j cap plus z1 k cap. So basically this displacement you can find final position minus initial position. You already know this, and you already know the force. Whatever force will be given to you, do the dot product of this and you will get the value of work done. Obviously work done basically is a scalar quantity, and it is a scalar quantity, so its SI unit will be what? Its SI unit will be equals to Newton meter, and that Newton meter can be written as joules. So we'll discuss the work done unit will be joules. One more thing which you have to remember, that work done work done can be positive, work done can be negative, work done can be zero. If the dot product is positive, that means if the angle between the force and displacement is acute, then the work done will be positive. If the angle is obtuse, then the work done will be negative, and if the angle is 90 degrees, then the work done will be zero. Okay, so these things you must remember. Now let me come to the next case, that if we say that force is variable. So if force is variable, force can be written as what? It can be written as Fx i cap plus Fy j cap plus Fz k cap. And displacement, small displacement ds vector can be written as what? This can be written as dx I cap plus dy j cap plus dz k cap. So in this case, what will be the work done? The small work done will be equals to F dot ds. So you can write it as Fx dx plus Fy dy plus Fz dz. Now if you want to calculate the total work done, directly you can integrate integration of Fx dx from x1 to x2 plus integration of Fy dy from y1 to y2 plus integration of Fz dz from z1 to z2. So basically this is how you can calculate the work done if variable force is given. Constant force, no need to do all these things. Variable force, you have to do these things. So I hope the basic concept of work done is clear to you. Let's discuss some questions based on this. So let's take the first question. Please understand, very easy, very simple. So suppose you have to calculate the work done by a force on the particle, And how the particle is moving? The force is given as 3 I cap plus 4 j cap Newton. The particle is going from origin to 4, 0 and then it is going from 4, 0 to 4, 3. So they are asking you what is the work done by the force on the particle. So you can either directly do this question by calculating the displacement vector, or you can do it by using the individual path. So let me do it directly. What will be the displacement? Since the force is constant, directly you can calculate the displacement vector. Displacement vector is always from the initial position to the final position. So what will be the displacement vector here? It will be equals to 4 I cap plus 3 j cap. Force vector is already given to you, that is 3 I cap plus 4 j cap. So if you will calculate the work done, you will do the dot product of this. You will get 4 into 3 plus 3 into 4. So what will be the answer? This will be 12. This will also be 12. The answer will be 24 joules. So work done will be directly 24 joules and it is a positive work done. You can also do it by another method, that you first calculate the work done from origin to 4, 0 and then you calculate from 4, 0 to 4, 3 and then you add the works. So that also can be done. That is another approach. Let's move to the next question. So in this question, basically what they are saying that there is a cart and that cart is moving with acceleration 2 meter per second square and it is starting from rest. That means initial velocity is 0. And there is a string which is having mass m, and because the cart is moving with acceleration, so obviously the string will go somewhat backward. This angle will be angle theta and it will go somewhat backward. Mass is given as 10 kg. They are asking you find the work done by the tension on the point mass in first 2 seconds. So obviously there will be some tension which will be acting here. Let us call it T. They are asking you what is the work done by this tension when this whole system gets accelerated by 2 meter per second square and in the first 2 seconds. So what I can do is I can first calculate the force acting on this mass, or I can calculate the tension which is responsible for creating the acceleration. So this particular particle, this mass is at rest with respect to this cart. So what is the horizontal force? What is the horizontal force on the particle? The horizontal force on the particle will be nothing but the component of tension. So if this is theta, this will also be theta. So horizontal force on the particle is T sin theta. But that T sin theta is doing what? That T sin theta is basically providing acceleration to this particle. Now whatever is the acceleration of the cart, that has to be the acceleration of the particle also, because with respect to the cart the acceleration of the particle is 0. So overall with respect to ground, the acceleration of the particle will be 2 meter per second square. So I will say the horizontal force acting on the particle is T sin theta. That will be equals to mass into acceleration. Mass is 10 multiplied by acceleration is 2. So 20 Newton of force, horizontal force, is acting on this particle. We have got the horizontal force. Now let us calculate the displacement. We know that the displacement of the particle is ut plus half at square. The initial velocity of the particle is 0 because the system is starting from rest. So I will say it will be half into acceleration is 2 multiplied by, in how much time I have to calculate? In 2 seconds. So I will write half into 2 square. So displacement will be 4 meter. Now I have got displacement also and I have got the horizontal force also. So what is the work done by the tension? The work done by tension is basically equal to the horizontal component of the force, which is 20 Newton, multiplied by the displacement of the particle, which is 4. So the answer will be how much? 80 joules. So basically please rely on the definition of work done. Definition of work done is what? The component of the force along the direction of displacement multiplied by the displacement if it is a constant force. So this was the second example of this particular question. Then let us talk about the work done due to gravity also. Now whenever we are talking about work done due to gravity, first let me explain the concept. Whenever we are talking about work done by the gravity or gravitational force, then gravity is basically a type of conservative force. You must know what is the conservative force. If you don't know, I'll discuss it. Conservative force is basically a force in which basically the work done by that force does not depend on the path. Suppose you want to go from one point to another point, then the work done will not depend on the path. You take by any path, the work done will be same. One more property of conservative force, that the work done in the closed path is always equal to 0. If you take a particle from one point to another point and again that particle comes back to the same point, or it forms a closed path, then the work done by that conservative force will always be equal to 0. Okay? So these two properties are very important, and one more property I will tell, that potential energy is only defined for conservative forces. So basically this is the concept of gravitational force. So since work done by gravity is not depending on the path, then how to write the work done by gravity? It is a very simple task. Suppose you want to write the work done by the gravity from point 1 to point 2. Okay? Let us suppose there is a particle of mass m and it is dropping from point 1 to point 2 and the vertical height between these particles is h. So obviously gravity will be acting in the downward direction, mg will be acting in the downward direction. So what will be the work done by the gravity? Work done by the gravity will be forces in the downward direction, displacement also will be in the downward direction. So I will say work done by the gravity will be mg multiplied by h and it will be a positive work done. If suppose you are going in the opposite direction, suppose you are going from point 1 to point 2 like this now, you are going in the upward direction. This is a particle of mass m but it is traveling in the upward direction. Obviously the gravity force is acting downward and you are taking the particle upward. So in this case, what will be the work done by the gravity? Here it will be minus of mgh. So what I am trying to say is, if you go in the direction of gravitational force, then the work done by the gravity will be positive, and directly you can write mgh, where h is the vertical height between the 2 points between which you want to calculate the work. And if you are going against the gravity, then the work done will be minus of mgh. I hope it is clear to you. So let me take that particular concept and let me apply it here. They are saying that there is a particle of mass m and it is thrown at an angle theta with speed u. Find the work done by the gravity during its upward motion. That means you have to find the work done by the gravity only till here, from point 1 to point 2. So what I said, there is no need to worry about the path along which the particle is moving. You only need to worry about the vertical height. And since the particle is going up, the vertical height is basically capital H. Now from projectile motion, we already know that capital H is u square sine square theta divided by what? 2g. This you already know from projectile motion, we have discussed it. So maximum height is u square sine square theta divided by 2g. And since you are going up and gravity is acting down, so work done by the gravity will be equals to negative of minus of mg into capital H. That will be minus of mg multiplied by u square sine square theta divided by 2g. So the final answer will come out minus of mu square sine square theta divided by 2. I hope it is clear to you. So this is basically the work done by the gravity. This is the work done by gravity. Next, let's move on to the next concept. Now there is one question which is based on variable force. There is a question which is based on the variable force concept, that there is a force which is varying with space x, y, z. If you will change, the force will change. And they are saying to you that you have to calculate the work done to displace the particle from 0, 0 to 2, 1, 3. So in that case, what is the work done by the force? Just now I told you, you remember one thing? Just now I told you that whenever you want to calculate the work done by a variable force, then it is always equal to integration of fx dx, fy dy and fz dz, and the limits also you can vary from x1 to x2, from y1 to y2, from z1 to z2. So let me apply this particular concept here. So what I will get? Work done will be equals to what? Work done will be equals to integration of fx is how much? X into dx, from where to where? X is 0 to 2, plus integration of y dy from 0 to 1, plus integration of z dz. Z is basically, y is basically what? Y, and z is basically what? Z. So z dz from where to where? From 0 to 3. Just you have to integrate it now. So what you will get? X square by 2, 0 to 2, plus y square by 2, 0 to 1, plus z square by 2, 0 to 3. So what will be the value of work done? Work done will be equals to, you will put x is equal to 2 here. So 2 square will be 4, 4 by 2 will be 2. So 2 plus, here it will come 1 by 2 and here it will come 9 by 2. 9 by 2 plus 1 by 2 will be 10 by 2, that is 5. The answer will be 7 joules. So work done will be equals to 7 joules. Basic simple concept, and you can easily do this. Chalo. Let's move to the next concept. Achha, next concept is basically related with what? Now we have understood the concept of work. That work done can be calculated by two methods, either variable force work done or constant force work done. Now once we are clear with the concept of work done, now let's go to the next concept, that is kinetic energy. So basically what is kinetic energy? Kinetic energy is basically the energy of a body because of the motion of the body. Any body, if it is having motion or if it is having some velocity, then it possesses some energy which is called as kinetic energy. So what will be the formula of this kinetic energy? Kinetic energy will be given by half mv square, where m is the mass of the body and here v is basically the magnitude of velocity. V is basically here speed of the body. Again, kinetic energy is a scalar quantity and its SI unit will be equals to what? Its SI unit will be joules. Kinetic energy is a scalar quantity and its SI unit will be joules and it will be given by half mv square. M obviously is the mass of the body, which we already know. Now one more thing, please understand, kinetic energy is basically depending on frame of reference. By the way, work done also depends on frame of reference. Work done and kinetic energy both are the quantities which are basically frame dependent quantities. Why? Because if let us suppose if there is a particle which is moving with some speed v. Now if the observer changes, suppose if I am also moving with the same speed v and I am observing that body, then according to me the velocity of the body will be 0. So in that case the kinetic energy with respect to me will be 0. That is why kinetic energy of the body depends on the frame who is seeing the body. In the same way, the work done also depends on the frame of reference. So let me write these points, that kinetic energy and work done depend on frame of reference. So please understand this thing, kinetic energy of the body and the work done applied by a force depend on the frame of reference. One more point I want to clear. One more point is there that I want to clear, that whenever we are talking about work done by internal forces, like work done by normal reaction, work done by tension in the string, work done by static friction, the net work done by all these forces, if they are internal to the system, what are the forces which I am talking about? Tension in the string, static friction and normal reaction. The total work done by these internal forces is always equal to 0. But if there is a kinetic friction acting in the system, then the net work done by the kinetic friction on the system will be negative because there will be a loss of energy. So always remember this particular point which I have discussed. You can write it on your own because we have limited time. So write it on your own, that work done by tension, static friction and normal reaction will always be 0 if you are taking the total work done of the system. I am not talking about work done on the individual body, total work done on the system. But total work done by kinetic friction in a system will always be negative. Okay, I hope these points are clear. So based on kinetic energy, there is a very famous example which comes, very common example. What they will say is, they will say that there is a particle who was moving with some speed v and the speed of the particle is increased by 200%. Keeping the mass constant, they are saying what is the percentage change in kinetic energy. These type of questions in kinetic energy normally comes. How you will do it is very simple. Suppose the initial speed was v. So kinetic energy will be what? Half mv square. Now the speed becomes v dash. V dash will become v plus 200% of v. What is the meaning of increases by 200%? That means whatever was the initial speed plus 200% of the initial speed will be the final speed. So it will be what? It will be v plus 200% means 200 by 100 multiplied by v. So it will be 3v. So the final speed has become how many times? 3 times it has become. So what will be the kinetic energy? K dash. If you look at kinetic energy, K dash will be equals to, it will be half m multiplied by 9v square. That is 9 times of the initial kinetic energy. That means kinetic energy has become how many times? 9 times. So what will be the percentage change in kinetic energy? Percentage change in kinetic energy will be final kinetic energy 9k minus initial kinetic energy k divided by the initial kinetic energy multiplied by 100. This is basically the percentage change in the kinetic energy. So kinetic energy will cancel out. So you will get 800% as the answer. So if the particle is moving with some speed v and its speed increases by 200%, then the kinetic energy will increase by 800%. I hope it is clear to you. After this, let me discuss the concept of, so once we know the concept of kinetic energy, then let me discuss the concept of potential energy and the concept of conservation of mechanical energy. So everything I will discuss here only. So first let me discuss potential energy. What do you mean by potential energy? Beta, if you talk about potential energy is basically a type of energy which is possessed by a system. And in that system, the conservative forces must be doing some work. Whenever there is a system in which some conservative forces is doing work, then basically that system possesses potential energy. Okay, we can relate this potential energy in one more case. Potential energy is basically the work done by the external agent to assemble a system in a particular configuration. So these are the two definitions of potential energy. Mathematically, how we will define potential energy? Mathematically, potential energy is defined by this concept that work done by the conservative force is always equal to minus of delta U. Work done by the conservative force is always equal to minus of delta U. That means I can also write it as work done by conservative force is equal to U initial. See, delta U means what? Delta U means U final minus U initial. So what will be the work done by conservative force? It will be U initial minus U final. Always remember, this is the one and only definition of potential energy. Basically, what is potential energy? Potential energy is a energy possessed by a system in which conservative forces do work. If there is a conservative force doing work, then it is basically spending its energy. Which energy it has? It has potential energy. If it is doing some work, it will be spending some amount of energy, so its energy will be decreasing. Whatever is the decrease in that potential energy, whatever is the decrease in that energy, that will be the work done by the conservative force. So WC is equal to U initial minus U final. One more thing you must remember, that potential energy change does not depend on reference. The change in potential energy does not depend on reference. Suppose if somebody asks you what is the change in potential energy because of some event, there is no need to define the reference where you have to take potential energy to be 0. But whenever you want to find the potential energy at a particular point, then always remember, at a particular point, potential energy, if you have to define, you have to first tell where is the reference potential energy, where you are taking as reference, and at that reference, what you are taking as the potential energy. So I can say potential energy at a point depends on reference. You have to specify the reference, then only I can say the potential energy at a point. Otherwise, I will not be able to tell the potential energy. Now, there are two types of potential energy here. One is the gravitational potential energy. What is gravitational potential energy? Very simple. Suppose there is a particle of mass m and you want to take this particle to a height h. Now, I want to know what is the work done by the conservative force. Here, who is the conservative force? First of all, tell me. Here, the conservative force is basically gravity, and gravity is the conservative force. I already told you. What was the definition of conservative force? You remember? The work done by the conservative force does not depend on the path. The work done by the conservative force in closed path is 0, and potential energy is always defined for conservative forces. So work done by the gravity will be what? To take the particle from here to here, the work done will be minus mgh. And this work done by the gravity, by the definition of potential energy, I can write it will be minus mgh is equal to U initial minus U final. So that means from here, the change in potential energy, U final minus U initial, if you will calculate, it will come out to be plus mgh. That means if a particle is taken against the conservative force, please understand very careful. If the particle is taken against the conservative force, then in that particular case, the work done against the conservative forces will be positive. And since the work done by the external agent is coming out to be positive, so the potential energy will increase. Please understand again. If any particle or any system is taken against the conservative force, that means the work done by that conservative force is coming out to be negative. Then always remember, the potential energy of that particular system will increase. U final will be more than U initial. U final minus U initial will be positive. I hope this particular thing is clear to you. If suppose the particle is going down, suppose the particle is going from here to here. In this particular case, what is happening? Work done by the gravity is coming out to be positive. And if the work done is positive, that is equal to U initial minus U final. So change in potential energy, which is U final minus U initial, will come out to be what? Negative, minus mgh. So in this particular case, what is happening? The work done by the gravity is coming out to be positive, but the potential energy is decreasing. So one thing, please understand it in your mind, that whenever you are doing work or whenever conservative force is doing work positive, then work done by the system will always decrease, or potential energy of the system will always decrease. Again, I'm telling, if conservative force is doing positive work, then potential energy of the system will always decrease. If conservative force is doing negative work, then potential energy of the system will always increase. I hope it is clear to you. Suppose somebody says to me that I want to find the potential energy at this point. So then I will say, please define the reference. If initial I am taking this, if I am taking potential energy to be 0 at this point, that means this is my reference. Then I will say that at this point the potential energy will be how much? This is the reference. So in this case, U initial is equal to 0. So at this point the potential energy will be equals to mgh. And since I am taking this as my reference, here potential energy is 0. So here it will be how much? Now in this case, U final is 0. So if you put U final 0, then here also you will get potential energy to be mgh. So always remember, if you want to define the potential energy at a point, then you have to go for the reference. You have to tell the reference, then only you can find the potential energy at a point. But if you only want to find the change in potential energy, then directly you can apply this formula, that work done by the conservative force is equal to U initial minus U final. And again I am repeating that point, that if the conservative force is doing a negative work, always remember, if conservative force is doing a negative work, then the potential energy of that system will increase. If the conservative force is doing positive work, the potential energy of that system will decrease. I hope this particular point is clear to you. In context of this, there is one more energy which is called as spring potential energy. Spring potential energy, or sometimes it is also called as elastic potential energy. So whenever we are discussing about spring potential energy, what it will be? Spring force is also basically a conservative force. Spring force is also a conservative force. Now when spring force is a conservative force, so spring force can be written as what? It can be written as minus of kx. Minus of kx, where x is basically the elongation from the natural length. K is called as the spring constant. We already know all these things. So what will be the work done by the spring? Work done by the spring will be how much? देखो ऐसे करते हैं. Suppose I take a spring and let us suppose spring constant is k, and let us suppose this was the natural length. Now let us suppose I displace the spring by a distance x. So what will be the work done by the spring or work done by the conservative force? It will be kx is acting backward, kx will be acting in this direction. Spring force, displacement is in the right direction, so it will be minus of kx into dx. From where to where? From x initial to x final. So what I will write? I will write it as minus of half k into x square, or x final square minus x initial square. This is basically the work done by the spring. Now I already know that the work done by the spring can be written as what? The work done by the spring can be written as, again, U initial minus U final. So U initial minus U final will be equals to minus of half k x final square minus x initial square. So I will write change in potential energy will be U final minus U initial will be half k into x final square minus x initial square. This is basically the change in potential energy in the case of a spring. So I have told you the change in potential energy in the case of gravity, and I have also discussed the change in potential energy in the case of a spring, half k x final square minus x initial square. Now in this case, if I take reference, if at natural length x initial is equal to 0 and initial potential energy is also equal to 0, then I can write the final potential energy as half k x final square. That means what? That if you are taking the natural length, you are taking the potential energy to be 0, when the spring is not elongated, when the spring is not compressed, there you are taking the potential energy to be 0. In that case, the potential energy will be equals to half k x final square. So this formula can only be applied if you are applying this condition, but this formula can be applied anywhere, there is no problem. So I hope these two potential energies are clear to you, spring potential energy and gravitational potential energy. Now after this, one more concept comes, that is the concept of work energy theorem. Work energy theorem. Work energy theorem states what? Work energy theorem states that if there is a system or if there is a body and on that body multiple forces are acting and they are doing work. Now that multiple forces can be spring force, it can be tension, it can be normal, it can be pseudo force, it can be frictional force, it can be any type of force. So what does this particular theorem says? This theorem says that total work done by all the forces on the body will be equals to the change in kinetic energy of the body. So what I can write? I can write that the work done by all the forces will be equals to what? That will be equals to the change in kinetic energy of the body. Now in this work done, everything can come. Work done by conservative forces also can come. In conservative, there are two categories. One is gravity, one is spring. I already told you how to calculate the work done. Work done by non-conservative also can become. Non-conservative means what? Friction is a type of non-conservative force whose work done is not depending on the path, whose work done, total work done in the closed path is non-zero. So friction is a type of non-conservative force. So work done by conservative force, work done by non-conservative force. Any external agent can also do some work. Suppose there is a system in which some internal forces also are doing work, and outside the system also some external forces also are doing work. So work done by conservative forces plus work done by non-conservative plus work done by external will be equals to what? Will be equals to change in kinetic energy of the system or of the body. Now we know that work done by the conservative force can be written as what? It can be written as minus of delta U. I told you U initial minus U final, or minus of delta U plus work done by non-conservative plus work done by external will be equals to change in kinetic energy. So I can write work done by non-conservative plus work done by external agent will be equals to what? Change in kinetic energy plus change in potential energy. So this is basically the concept of work energy theorem. The actual definition of work energy theorem is this, that work done by all the forces will be equals to change in kinetic energy of the body. But in the other cases, I can convert that particular format into this format also, that work done by non-conservative plus work done by external agent will be equals to change in kinetic energy plus change in potential energy. I can also do one more thing. That work done by non-conservative plus work done by external agent will be equals to what? It will be change in total mechanical energy. Change in total mechanical energy. Where what is total mechanical energy? Total mechanical energy is basically the sum of kinetic energy and potential energy. Kinetic and potential energy sum is basically called as total mechanical energy of the system. And this is basically the definition of that. Work done by non-conservative plus work done by external is equal to change in total mechanical energy. Now please understand one thing. From here only I am discussing the conservation of mechanical energy also. If in a system, the work done by non-conservative force and the work done by external agent is equal to 0, either non-conservative or external agent are not present in the system, or the work done by non-conservative and the external agent is basically equal to 0. So in this case, basically what will happen? In this case, the change in total mechanical energy will be 0. That means I can say that total mechanical energy will be conserved. Total mechanical energy will be conserved. Very important statement. And total mechanical energy was what? U plus K. So U plus K initial will be equals to U plus K final. Very important statement. What is this concept saying? That if there is a system and in that system you are able to recognize that the non-conservative force is also doing no work and the external agent is also doing no work, in that case the total mechanical energy of the system will be conserved and U plus K initial will be equals to U plus K final. I hope this entire analysis is clear to you. That was a very important discussion which you have done, and this is basically the concept of conservation of mechanical energy. So based on that, I have a question. Let me discuss that question first. Please understand. So let us suppose this question is there. What is the question saying? There was an inclined plane having angle theta, and this inclined plane is fixed. The starting half part, the L/2 length part was smooth, and the last half part of the inclined plane is rough. So this L/2 is rough and this L/2 is smooth. And they are saying if the block is released from rest, it again comes to rest just before it reaches the bottom. That means when the block will reach the bottom, it again comes to rest. So they are saying what is the value of coefficient of friction. Now in this case, what we will do? We will go by the concept of work energy theorem you can apply, or you can apply mechanical energy ka concept. Here, because friction force is also doing some work, so obviously the mechanical energy of the system is not conserved. If the mechanical energy of the system is not conserved, so we will directly go by which concept? We will directly go by the concept of work energy theorem. Who is the forces which are doing work? Gravity is doing work, obviously. Normal reaction will not do work because normal reaction is acting perpendicular to the displacement. The particle is displacing in this direction, normal is perpendicular to the displacement. So normal work done will not be counted, it will be zero. Gravity is doing work and friction will do work. And which friction will do work? Kinetic friction. Because the block is sliding on this incline, so obviously kinetic friction will do work. So work done by gravity plus work done by kinetic friction will be equals to what? Change in kinetic energy of the system. Now what is the work done by gravity? You already know that from here to here, the gravity will only depend on the vertical height. So what is the vertical height? The vertical height is nothing but total distance is L. So vertical height will be L sine theta. So gravity work done will be mg into L sine theta. mg into L sine theta. What is the frictional work done? See, friction is only doing work in this half part. So it will be minus of mu into mg cos theta multiplied by what? Multiplied by L by 2. Because only in half part it is doing work and the value of frictional force is this. Should be equal to change in kinetic energy is what? Change in kinetic energy will be 0. Why? Because initially also it was at rest and finally also they are saying that when it reaches the bottom, it comes to rest. So change in kinetic energy will be 0. So what we are getting? We are getting mg into L sine theta will be equals to mu mg into cos theta into L by 2. Let's solve this particular case. So what we will get? mg and mg will cancel, L and L will also cancel. So we will write 2 sine theta will be equals to mu into cos theta. So mu will be what? Mu will be equals to 2 into tan theta. 2 tan theta will be the correct answer. I hope this particular concept is clear to you. So this is basically how you apply work energy theorem or conservation of mechanical energy in different concepts. So let's move to the next concept. Okay. In the next concept, I want to tell you one more thing. See, for a particle, if there is a particle of mass m, always remember potential energy can be written as mgh. वैसे change in potential energy can be written as mgh. This change in potential energy will be positive. Remember, potential energy will increase if gravity or conservative force is doing negative work, and potential energy will decrease if conservative force or gravity is doing positive work. So this change can be either positive, either negative, depending on what is the work done by the gravitational force. But what I am trying to tell you is that for extended bodies, always remember potential energy or change in potential energy will be given by m into g into height of center of mass of the system. Please understand very carefully. Whenever you are going for extended bodies, extended body means a continuous body. It can be rod, it can be disc, it can be ring, it can be sphere, anything. For these quantities, for these extended bodies, always remember the change in potential energy, gravitational potential energy will be given by mg multiplied by height of center of mass. Like for an example, suppose I take one example. Let us suppose I say that there is a rod of mass m, and length L, and I want to know the potential energy of this rod. And let us suppose I say to you that potential energy at the bottom is taken to be 0. So what will be the potential energy of this rod? Potential energy of the rod will be m into g into the center of mass will actually lie exactly at the center, L by 2. So it will be mg into L by 2. So based on this, let me give you one example. I can take one more example here. Suppose if I take a half ring. Suppose if I take a half ring of radius r. This is half ring. And for this half ring, I want to know the potential energy. So what will be the potential energy? We know that the center of mass of the half ring is given by 2r by pi. Suppose the mass is m. So what will be the potential energy of this? It will be m into g into 2r by pi. M into g into 2r by pi. This is how you can define potential energy. By default, I am taking the reference at the bottom. Based on this is a very good example. What they are saying, please understand. So they are saying that there is a chain of mass m and length L, and it was initially hanging like this, that L by 3 part was initially in the air and 2L by 3 part was on the table. They are saying find the minimum work done by the external agent to pull the chain up the table. See, minimum work done means what? Minimum work done means that the chain should be pulled without any kinetic energy change. It should be pulled very slowly. So in that case, I know that work done by external agent plus work done by gravity should be equal to change in kinetic energy. But since you are saying it should be pulled very slowly, so change in kinetic energy is equal to 0. So work done by external agent will be what? Work done by external agent will be minus of work done by gravity. And I know that minus of work done by the gravity is written as U final minus U initial. So this is basically the work done by the external agent. Now how to write this U final minus U initial? Always remember, first define the reference. So let us suppose the reference is this. Finally, if you remember, finally this change will entirely come up on the table. So if I am taking this as my reference, the final potential energy will be 0. So work done by external agent is equal to U final is 0 minus U initial will be what? See, reference is this. What will be the mass of this L by 3 part? Mass will be M by 3 and its center of mass will lie somewhere here, which will be at a distance of half of L by 3, that is L by 6. So what will be the potential energy? Minus why? Because it is below the reference. If it will be above the reference, it will be positive. Since it is below the reference, it will be negative. So minus of mass is M by 3 into G into distance from the center of mass will be L by 6. So the answer will be mgl divided by 18 joules will be the work done by the external agent. So I hope it is clear to you that whenever you are taking the reference or whenever you are taking the extended bodies, the potential energy, specifically the gravitational potential energy, is given by mass into G into height of center of mass from the reference. If that height of center of mass will be above the reference, potential energy will be positive. If it will be below the reference, potential energy will be negative. Okay. So let's move to the next concept. Achha, one more thing let me tell you. Please understand. Potential, the conservative force, please understand one thing very carefully. There is a relation between conservative force and potential energy. Let me discuss that relation also. Relation between conservative force and potential energy. Whenever we are discussing relation between conservative force and potential energy, then always remember that conservative force can be given by minus of du by dx. Or before that, let me discuss the concept of how to write potential energy in terms of force. We know that the small work done by the conservative force can be written as minus of change in potential energy, minus of du. Now, we also know that du can be written as minus of small work done by conservative force can be written as what? Fc vector dot dr vector. So basically, if you integrate it, what you will get, u final minus u initial is equal to minus of integration f vector dot dr vector from initial position to final position. That means whenever you want to find the change in potential energy, remember, whenever you want to find the change in potential energy and conservative force is given to you, then you have to integrate the conservative force from initial to final. You will get the change in potential energy, but don't forget to put the minus sign. And suppose if you want to do the reverse thing, suppose if you want to do conservative force, you want to write conservative force in terms of potential energy. So how you will write? Conservative force can be written as minus of del u by del x I cap, minus of del u by del y j cap, and minus of del u by del z k cap. So basically, what will be the conservative force? The x component of the conservative force will be minus of del u by del x. Del means partial differentiation. The y component will be minus of del u by del y, and the z component will be minus of del u by del z. Here I can take one special case, that if conservative force is only in one dimension, is only in one direction. If conservative force is only in one direction, in that case, the conservative force can be written as, it can be written as minus of du by dx. That means I can also say that the negative of slope of ux graph, negative of slope of ux graph will give the value of conservative force, will give conservative force. I hope it is clear to you that if conservative force is given to you and you want to find the change in potential energy, then you can write u final minus u initial is equal to minus of integration fc vector dot dr vector. And if u as a function of x comma y comma z is given and you want to find conservative force, you have to do partial differentiation. And if force is only in one direction, then the negative of slope of ux graph will give you the value of conservative force. So I hope this point is also clear to you. One more thing let me tell, that if your conservative force is 0, then I will say that the particle is in equilibrium. Particle is in equilibrium. Now equilibrium can be of two types. If it is a stable equilibrium means what? You displace the particle from the equilibrium position and the particle again comes back to the equilibrium position. That is called as stable equilibrium. So if the particle is in stable equilibrium, conservative force will be 0. This implies du by dx will also be 0 because force is minus du by dx. So du by dx will also be 0. Potential energy will be minimum and double differentiation of potential energy will be equals to positive. If it is unstable equilibrium, in that case what will happen? Conservative force will be equals to 0. Du by dx is also equal to 0. But since it is unstable equilibrium, potential energy will be maximum and double differentiation will be negative. This is very important. They will give you an equation and they will ask you find the equilibrium and find the nature of equilibrium, whether it is a stable or whether it is unstable equilibrium. So I hope this particular point is clear to you. Please copy it down and let's discuss one question. Potential energy is given by x cube minus x and they are asking you the position of equilibrium and the nature of equilibrium. The same question which I told. How you will do it? Very simple. First you will find conservative force. Conservative force will be what? Minus du by dx, or directly you can find du by dx and put it equal to 0. So du by dx will be what? It will be equals to 3x square minus 1 should be equal to 0. So x square is equal to what? 1 by 3. X will be equals to plus minus 1 by root 3. Plus minus 1 by root 3. This is basically the value of x. Now once you have got the value of x, that is equal to plus minus 1 by root 3. Now please go to the next concept, that is checking for whether it is stable or whether it is unstable. Remember, if double differentiation will be positive, then it will be stable equilibrium. If double differentiation will be negative, then it will be unstable equilibrium. So double differentiation let us do. If you will do double differentiation, what you will get? You will get 6x. Now for x is equal to plus 1 by root 3, double differentiation is coming out to be positive. For x is equal to plus 1 by root 3, double differentiation is coming out to be positive. That means it is stable equilibrium position. This is stable equilibrium position and potential energy will be minimum for this, remember. And when x is equal to minus 1 by root 3, the double differentiation is coming out to be what? The double differentiation is coming out to be negative and this corresponds to unstable equilibrium position. This corresponds to unstable equilibrium position. So I hope this point is clear to you. Whenever u will be given to you, please differentiate it, put it equal to 0, find the points of stable or unstable equilibrium, then to check which position is stable and which position is unstable. Please again differentiate it, find double differentiation. If double differentiation is positive, it is stable equilibrium. If double differentiation is negative, it is unstable equilibrium. So I hope this point is also clear to you. Now let's go to the next concept, that is the concept of power. So work, energy, power mein work also done, energy also done, and now let us go to the concept of power. So what is power? Power is basically the rate of doing work. It is the rate of doing work. Or I can say it is the rate. It is the rate of spending energy. Basically, this is the definition of power. So again, power is basically a scalar quantity and its SI unit is basically joules, joule per second. And joule per second can be written as watt. There is one more unit which is kilowatt. 1 kilowatt is basically 1000 watt. And there is one more unit which is called as horsepower. 1 horsepower is basically 746 watt. So based on this, some units are there which you must know. Power can be categorized into two categories. One is average power. Average power can be written as total work done. Total work done divided by total time taken. It can be written as delta W or work done by time. Work done divided by time. This is average power. It can also be written as total change in kinetic energy divided by time, because we know that work done by all the forces is equal to total change in kinetic energy divided by time. In the case of instantaneous power, it can be written as dW by dt or dE by dt, where E is nothing but the energy of the particle, dE by dt. Now one more thing, if you draw a graph between work and time, the slope of work time graph will give you power. And if you want to know the total work done, dW can be written as P dt. If you integrate it, you will get total work done is equal to integration of P dt. If P is constant, if the power is constant, then you can take that power outside and the work done will be power multiplied by time. One more thing which you must remember, that instantaneous power can also be written as dW can be written as what? F vector dot ds vector. Yes or no? Divided by dt. ds vector by dt is what? Displacement. Differentiation of displacement is what? It is basically velocity. So instantaneous power can also be written as the dot product of force and velocity. So these things should be clear to you. This much is required, which you must understand in the case of power. So basically, let me do one question for you so that you understand the concept of power also. What they are asking, they are saying how much water a pump of 2 kilowatt can raise in 1 minute to a height of 10 meter. So basically average power they are saying, because 1 minute they have given, time interval they have given, and since you have to raise basically water to a height of 10 meter, so basically the work done will be equals to mgh. So power is given as 2 kilowatt. Power is equal to 2 kilowatt, that is 2000 watt, is equal to mgh divided by time. So 2000 will be equals to mass, you have to calculate, g let us take it as 10, height is basically 10 divided by 1 minute means 60 seconds. So what you are getting from here, this will cancel, m is equal to 1200 kg of water. 1200 kg of water. I hope this is clear to you. 1200 kg of water has to be pulled out. Basic simple concept of power can be discussed by this method. So these were concepts which were related to work, energy and power. We have discussed all the things in great detail. Every minute things I have told you. Some questions also I have taken so that you understand the basics of that particular thing. And now let us discuss the next particular topic, that is the concept of solids. So the name of the chapter is Mechanical Properties of Solids. Mechanical properties of solids. See, this I will cover in very brief because it is not a very difficult chapter and very less chances there that in this question will be very difficult. Very easy questions will be there. Let me quickly brief you about this particular topic. See, before this particular topic, we were studying till rotation, we were studying rigid bodies. Rigid bodies were the one in which even if you apply a strong force, the bodies cannot be deformed. But in practical setup, the body is always deformed. So basically that property due to which the body is deforming, that is basically discussed in this particular chapter. Now what is that property? Let me discuss. The name of that property is called as elasticity. The name of the property is called as elasticity. What is elasticity? Elasticity in simple terms, if I will say, then elasticity is nothing but the property of a body to regain its shape and size after you have removed the deforming forces. Let us suppose there is a elastic body, and let us suppose this is a body and I am deforming this particular body. I am applying force from both the sides and I am trying to deform this body. Then if I will remove my deforming forces, then the intermolecular forces which will be there inside this body, they will try to bring the body into its original shape size configuration. This property due to which it is trying to bring it back to its initial shape size configuration, that is called as elasticity of the body. So let me write quickly what is elasticity. It is the property of a body due to which it tries to regain its shape, size, configuration once deforming forces are removed. So if you remove the deforming forces, then whatever due to whatever property the body wants to regain its shape, size, configuration, that is called as elasticity of the body. Achha, one more thing, why it is regaining its shape, size, configuration? Because there will be some internal restoring forces which will be developed. Because of that, it wants to regain its shape, size. If the body is not able to regain its shape, size, configuration, then we will call that property as plasticity. So one more property is there. I'm just writing the property name, not that much important, so I will not discuss the definition. Just you should remember the name, that plasticity is basically opposite of elasticity. It is the property due to which it cannot regain its shape, size, configuration, that is called as plasticity. Now there was one scientist which was named as Robert Hooke, and this particular scientist gave Hooke's law. So what was Hooke's law? Hooke's law stated that basically under elastic limit, the stress is directly proportional to strain. Stress developed in a body is directly proportional to strain, and if you remove this proportionality sign, then you will get a constant which is called as the modulus of elasticity. So basically E is basically called as stress divided by strain, and this stress divided by strain is basically called as modulus of elasticity. Now what do you mean by this stress and strain, and what is modulus of elasticity? We'll discuss now. Whenever here three cases are there. Modulus of elasticity can be in terms of Young's modulus, or it can be in terms of bulk modulus, or can be in terms of shear modulus. The most important is Young's modulus. What is the meaning of stress and what is the meaning of strain? That also I will discuss by taking the examples. So first let's talk about Young's modulus. What is Young's modulus? Young's modulus is denoted by Y. It is given by longitudinal stress divided by longitudinal strain. What does it mean? It means that let us suppose you are having a body, suppose you are having a rod, and let us suppose you apply a force perpendicular to the rod, because of which this particular rod displaces by delta L. Suppose the original length of the body was L and displaces by delta L, then basically the longitudinal stress, obviously there will be, if I take any cross section, there will be some restoring forces developed at equilibrium. At equilibrium, the restoring forces will be equals to the external deforming force. This is basically F external deforming force. So longitudinal stress will be defined as what? Longitudinal stress, remember, it is also called as normal stress. So longitudinal stress will be defined as basically the restoring force per unit area of cross section. Suppose here there is a circular cross section. The area of this cross section is called as area of cross section. So longitudinal stress will be the restoring force per unit area of cross section. And if the body is in equilibrium, then it can be written as longitudinal stress is equal to the external deforming force per unit area. Always remember, stress is basically the property of the body. It is always depending on the restoring forces on the body. So basically longitudinal stress is actually equal to restoring force per unit area, but in the case of equilibrium, if it is in equilibrium, you can also say it is external force per unit area of cross section. This is basically the concept of longitudinal stress. Now when I will talk about longitudinal strain, what I will write? Longitudinal strain will be change in length divided by original length, delta L divided by L. This will be longitudinal strain. This will be a unitless quantity. This will be unitless. And this quantity will have a unit. The SI unit will be equals to what? Force per unit area, that is Newton per meter square, or sometimes it is written as Pascal. And what will be Young's modulus now? Young's modulus will be basically longitudinal stress, that is force per unit area, divided by delta L by L. So I can write it as F into L divided by A into delta L. This is Young's modulus. From here I can write the change in length will be equals to FL divided by A into Y. This is basically called as the longitudinal stress divided by longitudinal stress, that is Young's modulus of the material of the wire. Obviously the Young's modulus will not depend on the stress and strain. It is the ratio of stress and strain. It is a constant for a material. It depends on the material. It also depends on the temperature, but generally it will depend on the material of the body. Next concept is bulk modulus. So what is this bulk modulus? Bulk modulus is denoted by B, and this is basically the ratio of volumetric stress divided by volumetric strain. Volumetric stress divided by volumetric strain. What is volumetric stress? Suppose there is a body and it is kept in a medium of surrounding water, and because of that a lot of pressure is being applied. So the pressure, let us suppose the excess pressure is basically delta P. Because of that the body got deformed and the change in volume is basically dV. So basically volumetric stress will be the excess pressure applied. This is the excess pressure which is deforming this body. Excess pressure divided by the volumetric strain, which will be delta V by V, the fractional change in the volume with a negative sign. Why negative? Because if the pressure applied will be positive. Positive pressure means you are basically compressing that particular body. So if positive pressure is applied, the fractional change in the volume will be negative. But bulk modulus always has to be positive. So that is why minus sign will come, so that the bulk modulus becomes positive. Again, what will be the SI unit of the bulk modulus? SI unit will be again Pascal, because volumetric strain will also not have any unit and pressure is in Pascal, so SI unit will be Pascal. So bulk modulus is this. One more thing, please remember, there is one more concept that is called as compressibility. Compressibility is reciprocal of bulk modulus. It is 1 divided by bulk modulus. 1 divided by bulk modulus. Acha, remember one thing, out of solids, liquid and gases, the highest bulk modulus is of solids, then it is liquids, then it is gases. So compressibility will be reverse of that. Compressibility of solids will be the least, then liquids, then gases. Compressibility means what? Who can be easily compressed or who are not very easily compressed. So basically solids are very difficult to compress. Gases can be easily compressed. Understood the logic or not? So compressibility ratio will be opposite to this and bulk modulus ratio will be like this. So this is basically the concept of bulk modulus. Achha, one more thing, in thermodynamics sir will teach you that in thermodynamics basically the velocity of sound can be written as under root of gamma into P by rho, or I can also write it as under root of B by rho. So for isothermal process, always remember bulk modulus is equal to pressure, and for adiabatic process, the bulk modulus is basically equal to gamma times of pressure. Okay? This will be discussed in detail in the case of sound also. Next is basically the concept of shear modulus. Shear modulus. So what is shear modulus? Shear modulus is basically denoted by this. Shear modulus can also be written as modulus of rigidity. It can be written as modulus of rigidity. So what is shear modulus? It is basically the shear stress divided by the shear strain. Okay, this is not that much important, but you must remember shear stress upon shear strain. What does it tell? That suppose there is a body and this end of the body is fixed and you applied a tangential force on the body. The area is given as A. Because of that it got deformed like this. So basically some angle is phi. So shear stress will be tangential force per unit area divided by this angle phi. And this angle phi can be written as what? It is a very small angle, so it can be written as perpendicular. Suppose the length is L, perpendicular is delta x, so it can be written as x divided by L. So this is basically the concept of shear modulus. I hope these points are clear to you. This one you must remember in the case of solids. One more thing let me discuss, that is the concept of Poisson's ratio. Poisson's ratio. This also sometimes can be asked. Poisson's ratio is given by sigma. So sigma is basically what? It is lateral strain divided by longitudinal strain. Lateral strain divided by longitudinal strain. It is basically minus of delta R by R divided by delta L by L. So delta R, suppose this is a body and let us suppose you applied a force on both the sides. Because of that, let us suppose the body got deformed like this. The length of the body increased by delta L, but the radius decreased by delta R. So basically minus of delta R by R divided by delta L by L will be Poisson's ratio. Why minus is coming? Because again, if the change in length will be positive, that means if the length is increasing, obviously the radius will decrease. To keep that sigma to be positive, I will take a minus sign. Achha, one more thing. If we talk about the volume of the body will be what? Pi r square L. If it is a cylindrical body, then what will be the fractional change in the volume? Delta V by V. It will be 2 times of delta R by R plus delta L by L. Now delta R by R can be written as what from here? Delta R by R can be written as minus sigma into delta L by L. If you will put it here, you will get minus 2 into sigma into delta L by L plus delta L by L. So what will be delta V by V? Fractional change in volume, it will be 1 minus 2 sigma multiplied by delta L by L. If your sigma will come out to be 0.5, in that case, fractional change in the volume will be 0. That means volume of the body will be constant. So for only those type of bodies, those type of elastic bodies where the Poisson's ratio is basically constant, in that case, or Poisson's ratio value is 0.5, in that case, fractional change in volume will be 0 and the volume will remain constant. I hope these points are clear to you. So this was the basic understanding of solids and the basic understanding of work energy power, whatever we have discussed. So I hope these points are clear to you. And now we'll meet in the next particular lecture and we'll discuss the next chapters. Thank you very much.